Hello friends, welcome back to the channel. In this video lecture series, we will learn various numerical methods and its application. So let's start with the first numerical method, bisection method. So bisection method is generally used to find the root of the equation for a single variable. Before starting with this bisection method, first of all let's understand what is root of the equation. So there are various types of equation like algebraic equation, then trigonometric function, then transcendental equation. So root of the equation is nothing but the value of particular x for which whole function becomes 0. So for example, let's say if we talk about root of this algebraic equation, root of this algebraic equation, x square minus 5x plus 6 equal to 0. So what do we understand by root of the equation? Root of the equation means value of x for which this function becomes 0. So we have to identify the value of x in such a way that this function becomes 0, right? So if we find this is a quadratic equation, we can find the solution of quadratic equation using standard method, right? Like if we separate this minus 5x, so x square minus 3x minus 2x plus 6 equal to 0, right? So x will be common, x into x minus 3 minus 2 into x minus 3 equal to 0. So x minus 3 into x minus 2 equal to 0. So root of the equation is x equal to 2 and 3. So for the value of x equal to 2 and 3, this equation becomes 0. So root of this equation is 2 and 3, right? So this is just an quadratic equation. So there is a various standard method for finding the root of the quadratic equation. But what happens when the function is not as simple as quadratic equation, like a transcendental equation or higher degree polynomial, right? Let's say if the function is x raised to 5 minus 5x raised to 4 plus 3 x cube minus 5, something like this, higher degree polynomial. So root of such a equation you cannot find directly. There are no any standard method for finding the root of such a equation, right? So in such a cases we have to go for the approximate method that will give us the approximate root of the equation. So using these various numerical methods, we will learn how to find the root of this equation. And also if we plot this graph, let's say if we plot this x square minus 5x plus 3 graph on graph paper, so it will look like something like this. So it is a x square, so it is a parabola. So x equal to, let's say this is 1, 2 and 3. So something like this parabola. So this is our function f of x, and these are the two root of the function at x equal to 2, x equal to 3. On x-axis there is a x coordinate, on y-axis it is a y coordinate. Also we can write it x or y is equals to f of x. So this is the general concept of root of the equation, the particular point at which function intersect x-axis. So it is a quadratic function, so it has a two root. Now let's talk about transcendental equation. So transcendental equation. If the function is consist of logarithmic function, trigonometric function, exponential functions. So if the equation is consist of all those kind of function, then such a kind of function is called transcendental equation, like this: 3 times log x minus 2 e raised to minus 3x plus 2 times sine x. So it consists of one trigonometric function, one exponential function, and one logarithmic function, right? So this kind of equation, there is no any standard method to solve the root of such a equation. So we can use this numerical method to solve the solution of transcendental equation, right? So in next video we will see the derivation of bisection method, how it will be helpful, what are the advantages and disadvantages of the bisection method, and various other methods that we will learn in this video lecture series. So till then, I hope you understand the concept of root of the equation and why we required these numerical methods to solve the root of the transcendental equation. Do like, share and subscribe to my channel for such more content, and we'll see you in the next video. Till then, goodbye.